Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard puzzle, but it's basically two puzzles in one. And the puzzles are basically the setting is exactly the same. It's just that the rule sets are slightly different. So that's what if you look at them, you have two puzzles, both of which look exactly the same as in the setting, but the rules are slightly tweaked so that basically each of them is going to be different. I'm trying to figure out if I should do both of them at the same time and then have just one long video, or if I should set because these are really just two distinct different puzzles. Um, hmm. Well, let's get through the first part, and then we'll figure out if we want to make it just two videos or one long video. Um, yeah, I think that's what I'm going to do. I'll see how I feel about solving the other one, and then how long that might take. And yeah, we'll play it by ear. But know that this is basically two different puzzles again, and I'll post a link to both of them. There's actually one where basically it has combined. You can do them side by side, but the thing is, there's nothing to be gained by doing them side by side. So I think it makes sense to like just have one puzzle each in the view, because otherwise, if you have two, it makes it much smaller. So and it's harder to basically concentrate on one, right? And there's no advantage of actually doing both of them side by side because they're basically there's no the only thing that's the same is the setting, right? The rule's not going to change anything by that. So I don't know if this is actually very hard for one of them or if it's just very hard for the combined set, right? Because they're both chaos constructions rule set, and chaos construction, I typically find chaos construction at least hard difficulty level. So it could be that these are just two hard difficulty levels, but this basically it's extended, right? It's two of them. So that could be why it's designated as very hard, or it could just be two very hard puzzles. And if it's two very hard puzzles, well, I'll probably break it down into two videos because I don't want to be spending I don't want to be creating a 4 hour length video here to solve these puzzles. Anyways, these puzzles are chaotic choice. So they're both called chaotic choice. This one is the region borders version, and this is the region cells version. And they're obviously both by Manta Ray. Manta Ray created the setting and then basically tweaked the rules so that he could use the setting multiple times, which is pretty cool. Anyways, let's get to the rules. We have chaos construction for region borders. We have chaos construction, where we need to divide the grid into 9 regions, each comprised of 9 orthogonally connected cells. And every row, column, and region must contain the digits 1 through 9 once each. And I think that's the same also for the region cells version. Yes, that is the same for the region cells version. So what is an orthogonally connected region? It means you can go in an orthogonally connected region. You can go from that's too big, any cell in the region to any other cell in the region just by going through edges while staying within the region. So this is an example of a valid orthogonally connected region, because to get from any cell to any other cell in the region, you can just go through edges all while staying within the region. This would be an example of an invalid one, because to get from this cell to any other cell in the region, you have to either go through a corner or go through an edge while not staying within the region. This is also not valid, because while they can go to each other by going through edges while staying within the region. They cannot go to any of the other cells in the region by going through edges while staying within the region. So that's how chaos construction works. We have arrows. So this is going to be where it differs for the different puzzles. I'm going to just do the region border ones right now. We'll see how long it takes. If it's decent amount of time, I'll basically Actually, let's go through both of the different rules just in case. So that you can basically pick and choose which ones you want to do. In arrows in this version, the digit in an arrow containing cell defines how many region borders, not including the grid edge, can be seen from that cell in the indicated direction. If a cell contains multiple arrows, the cell's digit in the total number of region borders seen in all indicated directions. The cell's digit in the total number of borders. Is that a sentence? If a cell contains multiple arrows, that's a clause. The cell's digit in the total number of region borders seen. Yeah, that's not a sentence. I think it's supposed to say if a cell contains multiple arrows. The cell's digits count. The cell's digit is the sum. Probably is the sum. Oh, is the total number. Okay, so the in should be an is. Okay, so that I was confused by that. If a cell contains multiple arrows, the cell's digit is the total number of region borders seen in all indicated directions. Okay, that makes more sense. That makes sense. So, for example, this cell must be essentially the sum of all region borders seen in all of these directions. But it cannot include the edge of the grid, not including the grid edge. A cell with multiple arrows may see no region borders in one or more of the multiple indicated directions, as long as one or more region borders can be seen in at least one of the indicated directions. Right, so that's just saying that just because it points in other directions, it's not guaranteed to see a region border in that direction, right? It's just saying that we're counting the number of region borders it sees in multiple directions. So this cell sees all the region borders in these directions, and again, it does not include the edge of the grid. And yeah, it's the sum, essentially, the total number of region borders seen for a cell, right? And that's how region borders work. The region cells one, you still have chaos construction, but the arrows in this version, the digit in an arrow containing cell defines how many region cells. It's the same, he uses the same term, but actually, does he? No, it doesn't. It's region sum versus region borders. Right. So this is region defines. So a digit in an arrow containing cell defines how many region cells, that is, cells belonging to the same region as the arrow cell, can be seen from that cell in the indicated direction, not including the arrow cell itself. Oh. So it does not include the arrow cell. Interesting. And region borders block vision. So keep in mind for this one, okay, so this one, for example, okay, I should give an example of the previous one. So, okay, say, well, this is a lot of regions. Well, say we had a region border here, a region border here, and a region border here. This cell would count 1, 2, 3 region borders. So this would have to be 3. This cell would count 1, 2 region borders. So that would be 2. So that's an example of how these arrows work, right? And then this would count 1, 2, 3, and then it would also count however many here. But say there was no region borders here, then this would be 3 also, right? And again, you don't count the edge of the grid. So that is region borders as an example. What about region cells? So let's see. If a cell contains multiple arrows, the cell's digit is the total number of region cells seen in all indicated directions. So we have a small mistake there too. A cell with multiple arrows may see no region cells in one or more multiple indicated directions, as long as one or more region cells can be seen in at least one of the indicated directions. So say this was a region this way, right? Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. So say this was a region here. What this would count 1, 2 cells. So this would be 2 in this direction. Okay, let's do this actually. We're gonna do this way. So say this was a region. It's not actually valid, but say we had a region like this. This would count 1, 2 cells because it's blocked by region borders. So this would be a 2 if that were the case. This sees only 1 because it sees no region cells in this direction here. So this would have to be 1. This would see 1, so that would be 1 cell there because it sees that. It does not see that one because region borders block vision. And again, you do not, in this case, you do not include the arrow cell itself. This would see 1, 2, 3, 4, 5, and 0 in that direction. Or sorry, 1, 2, 3, 4. And that would be, therefore, 4. This would see 0, but obviously you can't have a 0 in normal Sudoku or chaos construction Sudoku either. So that doesn't work. But yeah, I just wanted to use this as a principle of explaining. And this would see 2 also, because it sees only 2 cells in this direction, doesn't see any cells there, doesn't see any cells there. So that's an example of how region cells work. And those are all the rules of both puzzles. And again, they are exactly the same setting, it's just that you have different rules. We're going to start with region borders, and thinking about it, I'm probably going to divide this into 2 videos, because I don't know. Chaos construction is usually pretty difficult, so it's probably going to be fairly difficult. But we're going to do region borders first, and we'll see about the next one. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's first draw the grid around the border around the entire grid, which again does not count for the number of borders that they see. So these two and these two have to be different from each other, because remember, every row and column must contain the digits 1 through 9 once each. So this then has to be a border, because if it's not, they're going to be seeing the same amount of borders here. Same with these two. This must be a border here because of the same reasoning. These two must be the same, have to have different borders. So therefore, this must be a border here for the same reasoning. This can see at most 1, 2, 3, or 4 borders. So this is 1 through 4. And this must see at least 2 borders here. So this is 2 through 5. Um, this sees 1, 1, 2, 3, 4, 5, 6, or 7. So this is 1 through 7, and this has to be 2 through 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This sees at most 1, 2, 3, 4, 5. So this would be 5. This sees up to 8. This sees 1, 2, or 3. So this is 3 at most. This sees up to 8. This sees up to 8, right? 1, 2, yeah. This sees up to 8. So anything that's pointing up and down or left and right can only see up to 8. Right. So 1, 2, 3, 4, 5, 6, 7, 8. Sorry. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. This is up to 8. This is up to 8. This has to be 1 greater than this. So this is... you have to see at least 1 here. So 1, 2, 3, 4, 5, 6, 7. And this is 2 through 8 here. That's all we have for that. This sees 1, 2, 3, 4, and 5 at most. Okay. Realistically, it's not going to be 5, right? If you had 5, it would be border, 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 border. I mean, technically that could work. Yeah, actually, maybe that is fine. Anyways. This has to be part of that region, so this is light. We're gonna make this has to be part of that region. It's dark. Okay, so this cannot be a border here, so we can remove 1 as a possibility here and here. You could have... Well, this could be many, right? Because there's a lot of different regions there. Hmm. Okay. Yeah, this is all we have. This could be up to 9. Any of the 3. Okay, so this we have 1, 2, 3, 4, 5, 6 as a possibility. This has to be interesting. So we have 1 guaranteed this way going down because this has to be greater than 1. Or sorry, this has to be at least 1. So then this is 1 that way. This is 2, that's 3. So this is at least 3. We don't know if there's more. I don't think this can ever be 8. If we have 8, that means all the... Yeah, it basically just has to be 8 straight lines that way, then, if that's the case. And that's never going to happen, right? Because this has to go that way. If you have 8 region borders, that means this is going that way, this is going that way, this is going that way, and it's going to have to be that way for all of them, right? And then it can just continues all the way across the border. So this can't really be 8, which means this can't be 7. for the same reasoning. You could do 8 this way. You could do, but the thing is, these could be regions, the same region here. The thing is, for the edges, it can't work for just one, right? I mean, can't have 8 there. Because the problem is on the edge, they have to go 1, 2, 1, 2, 1, 2, 1, 2, right? So therefore, this can't be 8 because you would force the same thing. You can have 8 there though, because or 8 here because you could do something like funky like that, right? And then you don't have to have all 9 regions being essentially vertical rows and columns. Let's see. Three. Okay, so this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's up to 8, so that's a lot. So this could be up to 9. This is obviously up to 9. This is up to 9. This is up to 9. Interesting. So this is going to be this plus at least 1. Right? Because this sees both borders in both directions here, which is exactly the same as that, and it must see 1 going that way. So this has to be at least 1 more than this. Could be greater than that, so this could be up to 9. Do we have anything else? Yeah, I think this is definitely going to be 2 different videos because this looks pretty difficult by itself. Hmm. What else do we have? There has to be at least one other border here. So it's really these versus these, right? So if there are no other borders here, that would mean this sees 1, this sees 2, this sees 1, and this would be 2. So there has to be borders somewhere here. Okay. Can it be between these? I think... I mean, it could be. I think there have to be 2 more here. There has to be 1 here and 1 here. There has to be at least 1 of these here, right? If you don't have 1 here... so if you don't have 1 here, any other borders that are between these 3 are seen by both, right? So right now this sees 1 and 2. This sees 1 and 2. So anything would add to each of these cells, but it would not add to here. So there has to be at least 1 here. And to have a difference, it has to be 1 here and 1 here, right? Because right now this is 1 and 2. Anything that's going to be in these cells are added to all 4 of the digits. So therefore, this has to steer clear of these cells here by an extra 2. So it must be like that. Interesting. So then this is 1, 2, 3, and 4. So therefore, this has to be at least 2. Sorry, at least 3, and this is at least 4. Light has to go down here. I don't know what these colors are going to be. Red, pink. We'll make this medium and this pink, I guess. This has to be a separate region. So we'll make that orange. This is definitely a different region than this, so this has to go down. But light has to go down also, because this is a region border. You cannot go all the way around here because then pink is going to be too small. So pink has to go down this way. Light has to go here. This is green. That means it has to go all the way there. Light still has to go out, so then it still goes there, which means... So light has to go to here, which means green has to go there. There has to be a region border this way. We don't know if this is the same region, so that, I mean, you could have more cells there. So this sees 1, 2, 3, this sees 1, 2, 3, 4, this sees 1 right now. We could have region borders here. This now sees, so these are not, you could have 1, 2, 3, 4 at most, so no 5 or 6. That means this can't be 6 or 7. This sees 2 at least, so it's at least 2. So we're going to do minimums here. 2. This sees at least 2, so that's 2. This sees 2 this way. And so this is cannot be 1. It sees 2 that way. It could see 1, 2, 3, and then 4, so it cannot be 5. This sees 0 that way. So that means this is up to 8. It sees 1 that way, right? Yeah, this sees at minimum 2. This sees also at minimum 2. So I guess we should mark that. We don't have anything else here. Can this actually be 5 and 4? Yeah, I guess so. There has to be a boundary here, so this cannot be green here. Because if that's green, it can't go around a 9-cell region. So this is going to be a different region, but we don't know what. So this sees, again, 3 at least. This sees 2 at least here. So this is at least 2. This is at least 2. This would match this. So this has to be greater than this. This sees 4. 1, 2, 3, 4. Sorry. So then this must be greater than that because it also sees that way. So this is 5 at least. These are the same, but in this sees 2 more. So this must see 1 this way, which means this and this sees 2 this way, guaranteed. So this has to be at least 3. Oh, that's interesting. So this can never be 2. If this is 2, this sees 1 more than that, so it's 3. This sees 2 more than this, so it would be 4, and this would be 5, but this can't be 2 through 5. So this cannot specifically be 2. This can't be 3. This can't be 4. And that can't be 5. But you could have 1 through 4. You could have 3 through 6. You could have 4 through 7. So this is guaranteed to be this set, right? This does not have to be 1 greater than these cells, though. So that's the reason why this could still be 1, 2, 3, 4, and then this would be 5. Maybe that leads to something. Maybe we should make that assumption then. Or maybe we should try 4, 5, 6, 7. That's interesting. So what happens if this is 4, 5, 6, 7? So then these are boundaries here. So we have boundary, boundary, boundary. That means this must go down that way. So this is region. You have orange, blue, yellow, and I don't know, red. That's kind of problematic, right? These essentially have to form some sort of weird... let's just... Yeah, this has to be basically lockstep. So we have the same problem in that situation. That might not be an issue. Maybe. The thing is that would force these to be essentially forms of long lines. Because these have to go in lockstep. And this would be these cells here, and then that would guarantee this is that way. But that's not possible. So then that cannot be 4. So we can't have 4, 5, 6, and 7 there. What about if we try 3, 4, 5, 6? So either way, this is 1, 2, 3, 4, or this is 3, 4, 5, 6. Either way, this you cannot have 3 or 4 remaining in this row. So this cannot be 3 or 4, therefore this can't be 2 or 3. We see 1 or 4 here. I think 4 is going to be kind of problematic also. So what happens if we have 4 that way? We have 1, 2, 3, and 4. This has to go there, this has to go there, this has to go there, this has to go there. So we'd have, okay, so this would be green, this would be red, let me make this yellow, blue, and orange. Green has to go that way, light has to go that way, pink has to go that way. Therefore, orange is here. Yeah, it would force essentially this. Okay, so this would not... Well, you'd have boundaries there. But this would force... 1, 2, 3, 4, 5, 6. So you'd have light, pink, green. So 1, 2, 3, 4, 5, 6, 7, 8, 9... 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be pink going that way. So you'd have orange going all the way here, blue going all the way here, yellow going all the way here, red going all the way here. Yeah. This would have to be red, yellow, and blue, and then this would not have a border. To go to. So this could have to be 0. So that's problematic. So therefore, this cannot be 1. It cannot be 4 and 5. This has to be 1 and 2. So this is 1 and 2, which forces this to be 4, 3, 5, and 6. So this is greater than 5 and 6, 7, 8, or 9. So this sees 1. This cannot be 1 or 2. So this is some combination of red and green here. This sees 2. That means this sees 2 and then across here. This has to see 3. So we see 1 and then 2 more out of these. This cannot be 6 here. This is 4, so this cannot be 4 here. So this is 2 or 3. If it's 2, it can't be 2. If it's 2, then it would see no borders here and no border here. But then this would be different regions. So this has to be 3. So that's 3, which eliminates 3. This has to then see at least 4. This can't be 3. So either a border's here or there's a border here. Obviously, this can't be 1, 3, or 4. It cannot be 8 because this is not a boundary, not a border. So this is pink or it's medium. We're not sure which, right? We have a border definitely here or here, but we don't know which. This sees 6 borders here. So this is at most 3 borders this way. So this cannot even, this can be at most 3. So this is at most 3 borders that way. So we have 3, 4, 5, 6, 7, 8 most. So this is 4 through 8. We're not sure which, though. Because it sees 6 borders here. It can only see 3 borders here. That's the reasoning why. This is only 3 borders this way, so that's 1, 2, 3 that way. So this is 1 through... it's guaranteed 1 that way, but that's only guaranteed. So it's 1 through 6 then. Remaining digits of row 1 are 1, 7, 8, 9. Hmm. So this is... This sees 1 border here, and then sees 2, 3. So this is at least... Well, we already know it's at least 3 because it cannot be 3. This is at least 4. 4 through 9. So there must be 1 more border at least this way. Remaining digits of column 1 are 3 through 9. Okay, 3 through 8 here because 9 can't be there. This sees also only 1 that way, but it could be just 2 that way. This sees 1 there. It's not... This cannot be 2. This can't be 2 because of 2 in the region. So this has to be at least 4 here. Interesting. So this sees 3 this way. But there's nothing that also sees all of these cells here. So this sees 1 this way, and it sees at least 3 this way. So then this has to be at minimum 3. It can't be... Well, this cannot be 3 then, so this is at minimum 4. Can this actually see 6? I think the answer to that is probably no. So 1, 2, 3, 4, 5, 6. So then this is 3, so it would have to be border, border that way. I guess it could. So that would be medium going this way. This would be certain color, yellow, orange, blue. I guess it could. And then gray. Yeah, that actually kind of works. Gray would have to go here, so this couldn't be pink. This would have to be a different color. Not sure what color that would be. Yeah, it's probably not going to work, though. Pink can't go around here. Yellow is different from this. Orange can't go around here. So that is problematic. So that means that we can't have a 6 there. But that's, I mean, you could still have 5. So, Can this actually be 7? Probably not, right? It would force all of these to be boundaries. This would obviously be pink. Medium would have to go that way. Therefore, this would have to go that way. So again, we'd have yellow. This has to be boundary there, then there. So this goes that way. That means that blocks there. You'd have to go all of these down. How does this would be pink. So then this would be light that way. This can't be pink. It can only be medium then. But then you could go pink there. Yeah, this is possible actually. Let's not do that then. Okay, so that can't be 6 though, because this is going to have all sorts of repercussions, right? If this is 6, that has to go that way, that way, that way. This should go straight down, probably. Straight down, straight down. Though actually, maybe that's okay. The issue was there an issue? I don't even remember. We have that, we have that. There, 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 there. So then this border has to go there and there. This is yellow, orange, and blue. Because these are separate regions, they have to go down. They have to go down another one. This has to be medium. Therefore, this can't be pink. Yeah, okay, the problem was that this is a separate region. And so this would be dark. Yellow could go here. This has to be a separate region. We'll make that red. So orange, blue, dark. Yellow has to go out. Orange has to go out. Blue has to go out. Dark has to go out. Medium has to go out. Pink has to go out. Light has to go out. Red has to go out then. Medium, pink. Right, this becomes some weird scenario. So again, this is 6. Dark has to go out. Blue, orange, yellow, red, medium, pink, light. So that's 7. So these have, yeah, these have to continue going out. So it's dark, blue. So then that forces dark to be here. Blue to be orange here. Yellow, red, medium. So medium and then pink. But medium has to finish here. Pink has to go here. Light has to go here. And then this, yeah, this is problematic. 1, 2, 3, 4, 5, 6, 7, 8. So light has to go here, but this has to have a border change, and it can't. So that's the problem with that. So that's the reason why it can't be 6 there. So this cannot be 6 in that scenario. Um. Hmm. Um. Hmm. So let's just list out what these can be. 4, 5, 7, 8, 9. Obviously, this is 4 through 8. So this cell is the same as that, except you have one more going. So there has to be one border here at least. So it could be 2 borders, but there's definitely one border here. Okay, so then this is at least 2, and it could be through 9. But 8 is very unrealistic. Actually, I think it's just impossible. What happens if we have 8 this way? It still could be, right? The thing is, this would have to go either that way or that way. This would have to go down, guaranteed, because we only have 3 lines here, not 4. So this would either go that way and down, and then this would go that way. So this would have to go down, this would have to go down. So you'd have border that way. This has to go down. So this would be orange. I don't even know if focusing on the maximum makes sense here, but there's at least one here. So this has to be the same as that. We have yellow. This has to be the same as that because it needs to exit. And then it could go either that way or that way. So orange has to go that way. Pink has to go down, which means light has to go down. Medium has to go down. Dark has to go down. So this is border here. This blue has to go down. Yellow has to go down because they can't just end there. So this is a mix of blue and yellow. That's certainly possible. So orange has to go down. Medium has to go down. Pink has to go down. Light has to go down. Pink has to go down more. Light has to go down even more. Green has to change somewhere, so then this would be all green, and then green has to go here, which means light has to go there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Pink has to go that way. Medium has to go that way. And then orange has to go that way, and it blocks yellow. So that's the reasoning why it can't be the full amount there. So this cannot be 8. Remove all the boundaries. So this can't be 8. Wow, this is kind of a pain, but so pink could go this way, right? So light could go there. That's possible. This is 0 this way. Can this actually? This is. there's got to be a better way of doing this, right? Then like basically focusing on all the maximums and hmm. Maybe I should focus on what these could be, right? Okay, so let's try to have one there. If we do have one there, that means two of these are the same, one of these is different. So we have orange there. So this can't be pink, that's medium. Therefore, this is pink. But orange could go here. So that's not helpful necessarily. It does force light to go this way, which means this can't be red, that's green. Um, you could go medium this way. I don't know if that's helpful. This obviously can't be 3 because of 3 in the row. This is 6. Yeah, this is only going to be one puzzle. I'm not going to do the other one. I'm not going to do the other one right after this. Uh, hmm. Hmm. Okay, I'm gonna pause because I really need to go to the bathroom right now. I'll be right back. Let me pause this and we'll pause the video. And I'm back. Let's continue. Okay. The problem is that it's kind of hard to figure this out, right? Hmm. 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 The only ones we can really kind of remove are the maximal ones, right? We can't really. If this is 1, well, it couldn't be that this is not even green, right? Never mind. These all have to be different in this row. There has to be a 7 somewhere. At least. But the thing is, there could be 9, right? Any of these could potentially pretty easily be 9. Hmm. Um. Hmm. Well, this is only sees 1 this way. So if there's 8 this way, that's going to be problematic, right? Say there was 8. Um, Therefore, you'd have light going here, pink going here, medium doesn't have to necessarily go there. So this would be 9 in that case. This would see 8 and would have to be 8. This would see 8, and then we have a problem. So that's problematic. So you cannot have 8 in row 8 borders in row 3. So therefore this cannot be 9. Right. So these count. So this counts all of them in row 3. This counts all of them in row 3. This counts all of them in row 3. These do not. So because of that, that means we have this is all of them in row 3 plus 1. You could have another plus 0 and another plus 2. So that means you could have 7 here. Ugh. Yeah. So we haven't ruled anything past 8 borders that we can't see. We still could potentially have 7. This could be 1, 2, 3, 4, 5. Right, that's why this is 3 at most. What other borders do we have? Yeah, this is probably the most promising, but the problem is... This... Oh. Hold up. This counts 0, and then it counts everything in row 4. This has to be 2 plus everything in row 4. So therefore, this is 2 more than this always. So this cannot be 8. So we have 1, 3, 4, 5, 6, 7. This can't be 4, so it's 3, 5, 6, 7, 8, 9 here. So this is this plus 2, essentially, right? Because it sees 2 here, and must be at least 1 that way. Not too helpful. Okay. I wonder if this is the harder one of the two puzzles. It sort of feels that way, but what happens if light goes all the way down here? If light goes all the way down here, that means green has to go all the way here. So then green would have to go there. This would be necessarily 3, and that does work. Okay. Not the best. This is at least 3 that way, or 3 that way. This is at least 3 this way. So this... Oh. This sees the same as this. So this could be 1 more or 2 more this way. Ooh. I think that's why this is 1 through 7. Anyways. What other arrows do we have? So this... No, we don't know if it could be 3. And then these would be fine. Again, it could just be 7 this way. 7 borders this way. Hmm. Okay. Hmm. Hmm. This could be dark all the way down. That is possible. Um. Hmm. Uh, hmm. Okay, divide this one character contain blah blah. Yeah, that's it. Hmm. This is quite difficult. Hmm. Yeah, this could very well be 1 and 2 there. It could just be 2 there. Hmm. We do know this is at least 3 borders here in this row. Oh, this can... It could be 0. Hmm. Ah, this could be 0 also in this direction, so that's why. Ugh. 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 So we have to have this C3, so therefore there's 2 boundaries here. So this has to be 3 different regions here. So we have green here, red here. Pink can't go around and block there. Medium can't go around. So these are 3 separate regions here. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this has to be 3 separate regions. So we're going to mark this as blue. We're going to mark that as orange. This is going to be yellow, and then we have a dark in one of these two. So this is dark in one of these two. This is orange. This could be yellow, and we don't... One of these is dark. That means red has to go somewhere here. This has to be a separate region, because you have to have a region border somewhere here. The only cell that can reach this cell is blue, so this has to be blue all the way down. Okay, so then this is guaranteed to be a region. Right, because red cannot reach all the way over here, because then this would have no borders. So red cannot continue all the way there. Again, these have to be separate regions. So we have accounted for all 9 regions here. So this has to be blue because orange can't reach it, dark can't reach it, yellow can't reach it, light, medium, pink, and light can't reach it. And these have to be separate borders. sorry, separate regions, because you can't close that region and have a 9-cell region there in between. So that's why this is blue. So this is the number of regions plus 0. So this is 0, and this is plus 1. So this is 1 greater than this, so this can never be 9 or 8. It's 4, 5, or 7. This then must be 1 greater than this, so this is 5, 6, or 8. This has to be then 2 at least greater than that, so it's 6, 7, 8, or 9. So we have 2 borders here, which makes sense. We have red and green going out there, at least. So that actually makes a lot of sense. Okay. So this is a border here. It still could be 2 borders that way. This is 1. Okay. So this counts the number of borders here. This is the number of borders here plus 1. This is the number of borders here plus at least 2, and it could have 3. Or more. Okay, so that was interesting about this aspect. Okay. There's no way yellow, medium, and orange can stay with just entirely within this region. So they all have to go down. So you have to have yellow going down, medium going down, orange going down. So we necessarily have to have 3 regions going down here. So that's, and medium also has to go down. So you have to have a medium going down, a pink going down, a yellow. So this is going to be a lot of, I think this forces this to be 7 then, right? So we have pink. So you're going to see, you have green, light, pink, medium, yellow, dark, orange, and blue all going down. So this must be 7 then. So this has to be 7, this is 8, and this must be 9. So this, okay, so then that means this can't be 7, because all of these colors have to go down. And so therefore they necessarily have to have 8 regions in row 3, going through row 3. So this can't be 7, 8, or 9. There's no 7, 8 here. The remaining digits in row 5 are 1, 2, 4, 5, 6. And we have to have 7 boundaries here. So this is going to be, so we have pink, gray, gray or yellow. This is going to be yellow or dark. So this has to be orange here, because there's no other, if you cannot be another color. This could be orange or dark. So this is the way that this works. This then, so you can only have 2 colors at most. Well, you have to have, one region has 2 colors in row 3. The rest has to be, so this is 9, which eliminates 9 here. It also eliminates 8 in the rest of the column in row 1, or column 1. So this is 9 here. So we can only have at most two of one region in the same color in row. Well, you have to have one region which has two, and then all the rest of row 3 has to have one of each color. So this we have 1, 2. This has to be at least 2. Can it be less? Can it be 2? I don't think so, right? We have orange can only have 2, and therefore this would be dark. So this has to be at least 4 or 5 here. Interesting. You could have 4 going that way and 1 going that way. This is 3 either way. Hmm. This has to be orange because they can't block off that. So this sees at most 2 this way, which means this is at most 4 in here. So this cannot be greater than 4. It's 1 through 4. So this sees 0 there. Okay, so this, what about this? Can you ever have anything that's all fully in this region? I think the answer is also no in row 4. But this, again, you cannot have the full 9 here. Well, maybe you could have red. I don't think, yeah, no, you can't fill in all of this. One region cannot be just all 9 here, right? In the first 3 cells. So doesn't this have to be... Oh, this is 2 plus that. So then this has to be 9. So this has to be 9 here. And this is 7 cells. Because you have, again, the same situation, right? You could have light, pink. So this is light or pink. This is pink or medium. This is medium or yellow. This is yellow or dark. You have orange and dark here. And this must be orange. So this has to be, yeah, because you can't fit any 9-cell region in the what's remaining here, given the constraints. So they all have to go down through row 4. That's 8 regions here, which means there are 7 boundaries this way, at least. And so this is this sees 2, so therefore this is 7 plus 2. So this is not 9 remaining in column 1. So with 3, 4, 5, 6, 7. Is it still restricted here? I think so, actually. So this could be gray or yellow, medium or yellow. So I think that's the case there. Yellow and dark here, orange and dark here, right? So that's the same scenario. Again, none of these can be fully in here, right? You have to have, you can have 7 yellows at most, technically. 7 darks, 7 medium. So they all have to go through row 5, which means this must be at least 7 because you have green, light, pink. All the regions are going through, so this is at least 7. and this has to include 1 here. So this is guaranteed to have 7. This has 6, so this must be 1 greater than this. So this has to be 8 and 9. This is 7 or 8. So we have 1 or 2 in this column here, because there are 7 required here. So this has to be 1 or 2 going down. So again, so this could be green or light. It cannot be red because then that would block off. Well, it technically could be red here. Yeah, technically could. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this could also be red. This is definitely orange. So now we could have a full set of 9 now in row 6. So this doesn't have to be completely there. This is orange or dark. Red cannot reach there. Where can red reach? Red can reach up to here. So technically any of these could be red. Technically. Can you have green here? No, that would block up the light. So this is light or pink. This is pink or medium, because again, if you had light go here, pink is blocked off. This is yellow or medium. This is yellow or dark. And these are the same. That's interesting. So if red were one of these, then light would have to go there. Pink would go here. Yellow would go here. Medium. Dark would have to go here. Orange would have to be here. Wait. If this is red, this is light, pink, medium, yellow, dark, and orange. Right. Okay, so then that would be the case there. Interesting. Huh. This sees all of this, so this has to be 7 also. So this is 7. No 7 here. And this is 0 that way. This sees all 7 plus 2. This sees... It could be 1, 2, 3 regions. So it sees at least 2 boundaries. So you have orange. No, you have to see 3 boundaries. Right? Because between dark and orange and blue. Wait, it's 2. Okay, so it could be 2. 2, 4, 5, 6, 7, 8, 9. 2 boundaries here. We are not guaranteed a boundary there. So there's nothing there. Hmm. Oh, what about this way? So we have pink. So 1, 2. Guaranteed 3. Guaranteed 4. Oh, well, that doesn't change anything there. Okay, never mind. Remaining digits of row 2. Let's just do that. It's 2 through 9. That's a lot. 2 through 9. This cannot be 279. This could be anything. No 3, no 5, no 6 or 7. That's pretty broad. Hmm. Red can go up to here. This could be dark, though. Hmm. Hmm. Oh, this is at most 2 this way. Right? Because this is 1 more than this. This sees 6 here, and it's either 1 or 2 this way. This sees 7 here, and then it's 1 or 2 this way. So this is 1 or 2 at most this way. 2, 3, 4, 5. So this cannot be 6 anymore. We technically could still have 8 that way. Remaining digits of column 9. 1, 2, 3, 4, 5, 8, 9. No 9 here because of 9 in the row. Hold up. This has to be 3 at least, right? You have border yellow, orange here, yellow or dark here, and then this would have to be yellow to extend out because you can't have a full 9 here. So this has to be at least 3, which means this can't be 2. Okay. So in column 6, we have a guaranteed 1 or 2 borders. Oh, that's interesting. So row 3, we have 7 borders. Row 8, we have row 4, we have 7 borders. Row 5, we have 7 borders, at least. But we know row 4 has 7, row 3 has 7. We don't have anything about column. Oh, this cannot be red. If we go red all the way around here, that's a lot of... This is 7 borders, and then this would have to red, to green, and then to red again, which is 3. So 7 plus 3 would be 10. So this cannot be red here. So this is green or light. So that means... Okay, so red has to go here. Because green has to be somewhere here. So then this must transition light to green, then to red. So therefore that forces red to be here. So this could be green or light. You cannot go green here because light would be cut off. So this is green or light. This could be red, green, or light, and this could be red, green, or light also. That cannot be light. It's red or green here. Hmm. Okay. Huh. Hmm. Oh, this can't be 1. If this is 1, because we know well, not necessarily. You could have a border here. Dang it. Oh, no, this can't be 1. If this is 1, we have a border here, definitely. If this is 1, that forces it to be 2, and there must be 2 borders amongst these cells. Well, there's only 1 here, so therefore there have to be 1 here, so this can't be 1. Okay. So I think this always has to be greater than that, right? Because so... Right. If this were 2, this would have to be 3. At least. This has to be at least 1 here. We have 1, 2. You could have 2 pinks, but then you would necessarily have... Okay. So 1, 2, 3, 4. So 1, 2. 3 definitely, 4 definitely. And we have 1 going this way, so this can't be 4. This is at least 5 or 6. You could have all 5 of these be that way, and then you have 1 going that way. Or you could have 4 going that way, and then 2 in this direction. But this is 2 at most. Interesting. So this could be 2 plus 7. Or it could be all 8. 1 plus 8 is also possible. So we have 1 or 2 in column 6 borders. We have 1 through 4 in column 7. Okay. Oh, this is an arrow too. So 3 through 7. That's interesting. Could certainly actually be 3 by that time, right? Because you could have a full set here, right? And then you could have full sets here, potentially. How many could you have here? Actually, that is kind of a question. So you're guaranteed... Okay, so how many cells are here? We have... It's 7 by 6. That's 42. And then plus 1. 43. 43. These have to be at least 6. 6, 6, 6, and 6 for all the regions that are there. So you definitely have 1 here. So 6 light. So 43 at most. And then you have 1, 2, 3, 4, 5, 6 regions. So 43 times... So 43 times... not times 3. It's 43 minus 6. So all of them has to have at least 6. Actually, this has to have 7 to even get to here. So 7 for light, 6 for pink, 6 for medium, 6 for yellow, 6 for orange, and 6 for dark. So that is... So essentially subtract out that. It's 42 minus 6 for all the 6 regions. So that's 6 remaining. So that means at most, so you could have all of them still going through. We have the definite blue there. So that means this could be 7 still. You could have all 7, or sorry, all 6 going through. You can't have all 7. No, all 6 going through. Right. Well, that includes green. So that's why it could be 7. The fewest you can have as regions would be minus, you have 6 for all the others. That means you could finish 2 regions up. So therefore you cannot have 2. You could have 2 not be in row 7, which would give you I think it has to be 5 then, right? 5 borders? Because you have the blue border, you have 4 of the regions still having to go through. You can't have 3. I know that that's the case. Because you have to go down. Can you have 4? You have... Yeah, because this has to be green or red. So therefore, since this is green or red, you have the other 4 different regions. And then you have blue. So that's 6 regions, which means it's at least 5 boundaries that way. Huh. Okay. This has at least 1 boundary. I think it has to have 2 at least, right? I mean, if... So say we try to have 1. Well, this would have to be all red or all green for the rest, and that's not possible, so this can't be 1. This is pretty hairy logic. Definitely very hard. Yeah, it looks like these are 2 very hard puzzles. Oh boy. So if this is 0, that would mean this is yellow, yellow. Which would mean this is not pink, that's medium. And I think that's incorrect. Right, so this is yellow, yellow. You have a border between dark and yellow. You have a border between dark and orange. And then you have a border between orange and blue, but that's only 3. So this cannot be yellow, which means this has to be medium. So you have to have a border here. That's 1. That means this has to be yellow to go down. This has to be dark to go down, so this can't be orange. This is dark. So there we go. So then we have necessarily border here, border here, border here. So this counts 1, 2, 3, 4, and you have a border here, so this is 5. So this is 5, which forces this to be 6. There's no 5 or 6 here, no 6 here, no 5 or 6 here. This is 2 or 4. So dark has to go here. Yellow has to go here to make border. This has to be, so this is 6. Which means we have 1. Then across pink is 2. To light is 3. To 4. So this has to be 2, which makes this 2. So this is 2. That forces this. So there's 2 borders. Actually, we don't know about this. This could be 1 or 2. But we have 2 borders here. This is 6 plus 2 then, which makes that 8. So this is 8. This is 1. No 1 or 8. No 1 or 8 here. This has to be 7 plus 2, which is 9. This is at most 2 that way. It could be 3 that way. No 6 or 8 here. No 5 here. So dark, this has to be yellow, so this can't be orange. Therefore, it's dark. So we have dark here. This could be yellow or dark. We're not sure. So this is border. And border here. Dark has to continue out, so this can't be orange. That's dark. Dark could technically do... Oh, yellow has to go here, so this can't be orange. Or sorry, can't be dark. So dark has to continue on here, so that's dark. No 9 here because of 9 in the column. Okay. We have border here. This has to see 1 at least. Okay, so this sees 1, 2. This must see 1, so this must be 4. So therefore, this must see 2 here. So this is 2. So this sees 2 borders here. This can't be 2 or 4 then. Hmm. 1, 2, 3, 4. This is 5. So no more 4s in row 3. This is 1 or 2. This is 1 or 2. You could have border here. So we know there's 2 borders in column 6. We know there's 2 borders in column 7. Orange has to go down here because dark cannot go this way. Let's see. 1 eliminates 1 as a possibility here. So that's 2 and 3. Five eliminates 5 here. So we know there's 1 border here. This can't be 9. So we have 1, 2 here. We have definitely the border between black and yellow. So that's 3. We have that border here, 4. But we don't have any other restrictions, really. sees 1, 2, 3, 4. It sees 2 more here in this column. We have 7 here plus 2. This is 6 plus 2. Um, hmm. If this is dark, this has to be 1 border that it sees there. If this is yellow, then this must be 2 that it sees there. Okay, this is border here. Border here. Yeah, this is pretty difficult. No 2 or 9 here. Okay, so borders, column 1 we have 1, column 2 we have 2, column 6 we have 2, column 7 we have 2. We don't care about column 8. Column 9 we have 0. We don't know about column 5. We don't know about column 4. We don't care about column 3. Row 1 has 6. Row 2 we don't care about. Row 3 we have 7. Row 4 we have 7. Row 5 we have 7. Row 6 we also have to have 7 now. Well, that's not true. It could be 6. It doesn't, we don't care. Row 7 we don't know. Row 8 we don't know. Row 9 we don't know. Okay. Green needs access to a 2. Orange can go 3 more. So orange can go to here, to here, to here. Dark could go all the way down here. It could go 4 more. So 1, 2, so 1, 2, 3, 4. So to here. So dark can go all the way to here, to there. Yellow has 1, 2, 3, 4, 5. 6, it only has 3. From this spot, though, could also work. Yellow could go here to here. It could technically go down to there. It cannot close off here, medium. Actually, dark can't go here. Okay, so... Okay, that's not right. So, orange cannot... Okay. We do not have a full set... Well, we could have a full set of yellow, right? So we could have all yellow there. We cannot have a full set of dark. We could have either a full set of yellow or medium, technically. So one of yellow or medium. So orange cannot go the full way here because dark still has to go out. So orange can go only up to here. Technically it could go to here. So these are possible. 7, 8, and 9 that way. So orange can go to here. Dark could close off yellow, but it cannot close off medium also. So dark could go to here. Obviously could go here all the way down. And could go any of these. Yellow could be full here. That's possible. Red could obviously just go all the way across. It could go up one here. 7 and then there. So that's possible too. Up to here. So this is red. So any of these could technically be red. So we have dark yellow. Cannot cross that way because... So yellow could be any of these. Cannot... It could block medium, but it can't block pink. So yellow could get to here. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. 7, 8, and 9. It could... if it goes that way, it would block dark. So it cannot go that way. So yellow could go there to there. It can't reach all... Okay, this is 1... Okay, this is yellow, so this cannot be 3. Medium cannot be 5. So yellow could go again 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot reach here. So this cannot be yellow. Oh. Dark can't reach here. This has to be red then. Because medium can't reach there. Pink can't reach there. This is guaranteed to be red. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is guaranteed to be red here. Because yellow cannot reach. Yellow is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 at most. Dark could reach all the way down here. But this is guaranteed to be red. So we have 6 red here. That means we can only have 3 more. So this cannot be red here or here. So no red there. This can't be red for the same reason. So yellow or medium. So 6, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is these are guaranteed to be red. Okay. Medium could do any of these. Cannot block off red anymore. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could go here. I don't think it can ever reach there. Because the problem is it would block off yellow. So how would it get here and then not block yellow? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, right? It would have to be 1, 2, going that way, but then it would block yellow. Because that would be 1, 2, 3, 4, 5, 6, 7, 8 at most yellow. So then medium can go all the way down here, can go here, cannot block pink. Pink can go any of these. Cannot block red. We need... Pink cannot go here, because then that would block yellow or medium. Actually, it would block medium. But you could have all medium... Well, maybe you could have pink there, then. All medium here. So that's all medium. Okay, so this is guaranteed to be red. Definitely. So since this is red... we have a change from yellow to red. We need another change here. This has a change. This is red, and this is... Okay, so this is a change. So, well, we don't know. Here, we don't know either. Okay, this cannot be all dark. So this can't be dark here, which means this is red. So we have 7 red, which eliminates red from these cells here. So we have a change from dark to red, but we need another change here. So that means orange has to go here because yellow cannot. If we go yellow, then dark is blocked. Well, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I can't go around and dark having there. So that means orange has to go this way, which means this can't be orange also. One of these is orange here, at least. So this is 8 reds, which means this can't be red, and none of these can be red. So this is green or light. These could be light here. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these could be light. These could be green. Not red, green. 1, 2, 3, 4, 5, 6. It would block off light there if that's the possible, so this can't be green there. But green could be there. Green could go down to here too. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the extent. Technically green could go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then pink could go down here. Is that right? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. No. So green cannot reach there. So we know this is all red because orange has to go here to give you a boundary between orange and red because we don't have another boundary here because it's all dark. So it must be down boundary from dark to orange and orange to red. So this can't be dark. We have 8 cells here. 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh. So this cannot be orange here. So we have 17 cells which require orange or red. That means we have one more that's red or orange, but we don't know which. Okay. So we have 2 here. We have red. It could be to... So this red is going to be to yellow or dark. If we try to have a medium here, that would be a switch from yellow to medium to yellow dark to red. And that's not possible. So this cannot be medium. So we could have a switch from yellow to dark here, or a switch from yellow to dark here, or a switch from yellow to red here. We don't know which. This is 8 reds. It could be 2 oranges there. Okay. Interesting. We have a change here to red. If this is green, you can only change once here. So this cannot be green. This has to be light. Interesting. So this is a change from light to here. To green. Green cannot... Green could... No. If it goes green here, that's a change from light to green, green to light, and then light to red eventually. So that's too many. So this cannot be green. Therefore, this is light, which means these are both green. Green has to go out to here. So that's done there. So then this is done. This has to be 3. Because we have a 2 already in the light region. So then this is done. We have boundary here, boundary here. This is done as a boundary. We have 1, 2, 3, 4, 5, 6, 7, 8. We need one more for light. That means, well, you could have 7, you could have 6, 7, 8, 9. That still works. This is boundary. So this is 3. Remaining digits of the column 2, we have 2, 4, 5, 6, and 8. Obviously, 2 cannot be in the light region because we already have a 2 there. So 2 has to be one of these two. Okay, this can no longer be 8. We see at most 1, 2, 3, 4, 5, 6 cells, borders. But red can only be once here. And so we have a red. We could have red, so this is at least 3. We need access to a 2. So this has to be at least 3 because red has to go up. So then red cannot be more than all 5 cells. So whereas the 2 in the green region, it has to be here. So this is 2, which means this can't be 2 here. This sees only one region, so this is a 1. So that means, sorry, one border. So that's 1, which means this can't be 2. No 2 here. We have to have a 1 in the red region. This can't be red then, because we're missing a 1 in row 9, and the red has to be one of the reds in row 8. 8 and 9 here. This digit must be the same as that, so this cannot be 7 then. So these are the same digit. We have 1 light here, which means we have 6 pinks in column 3. And then we have 3 more in column 4. But we don't know where it is. Okay. This is a guaranteed border here. This is a guaranteed border here. So we have 1, 2, 3, 4 guaranteed. And then we have a red popping up somewhere. So that's 5 guaranteed. So this is 5 or 6, which matches that. So that's 5 or 6. This is a border here because it can't be red. So this only sees 1 this way. It has to only see 1 here. This sees 2 and 3. Or it could be another 1. So this is 3 or 4 here. We have boundary here. We have definite boundary here, so that's 2. 3, 4, and then definitely one between yellow and dark. So that's it cannot be 4. It's 6, 7, or 8. Okay. Okay, so all these arrows are done. This one, can it have 6 or 7? Can it have 7? Well, yes, it could do something funky like this, right? Or not completely like that, but something along those lines, right? Uh, hmm. That's the reasoning why you can't restrict that one very much. Those long ones very much. So this is guaranteed to have one here because it doesn't have that one there. We know there's two total here. And it's either this is black and that's yellow, or it's one of these. Um, hmm. If this is yellow, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that could be 9. So that's why that can go that way. And then you have mediums going here, which is possible. Hmm. Can this actually be 2? That's maybe another question we should ask. If we have... Well, it could just be all medium down there. No, it can't, because that would block pink. So it would have to transition from medium to pink, and then pink to red. That is possible, right? We have 6 here, 7, 8, 9, and then this is all medium. Yep, that could be 2. This is 1 here. We don't know if it's 1 or 2 there. That 3 here eliminates 3 here. Can this actually be... Oh, yeah, right. We already thought about that. 7. Let's try 7. So if we had 7, what would it look like? It would have to be all of these. Okay. That's funky. This is not red. So neither of these would be red. So this would be medium, which means this would have to be medium. I don't think that works. This is medium, and then this has to be all medium that way. So this would all be medium. This would be medium. But then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 mediums. So cannot be 7. Can it be 6 is kind of the question then. Okay. If we have 6, we could have pink go 3 times. It could be 1, 2. Well, we know 1 light is here, right? Which means it cannot go pink, 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 which is sort of what I have to do for the 6, right? It would have to be 2 pinks in a row, and then a pink again. So let's try that. Let's try it with this. Then this can't be pink. Then this would be pink. So necessarily would have to do something like this, right? Clear, this would be medium. Can it do this? So that would be 1, 2. So 1, 2, 3, 4. It would have to be 5 and 6. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too large. What about if we did, so again, 6, the problem is, yeah, it has to be 1 and then 2 more to have that set, right? So then you could have, this is like this. But then the problem is, this would have to be, maybe you could have 2 reds, but you can't have 3 pinks there then. Well, I guess you could, yeah. You can't have pink pink because that would block off dark medium. You can't have pink pink here because it would still block off, well, I mean, that could work. Technically. So you could actually have pink here. But then the problem is this doesn't become 6, right? This is a full set there. So you can't have 6 here at all. Either. Right. How did I? Okay, so let's remove that. So pink could actually go this way. It could block off medium, right? But it can't go here because that would block off yellow and medium, which is not allowed. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could actually be pink also. So this has to be 2, which means it's medium. Then you have to have pink somewhere here. And then it has to be red. So this cannot be medium here. It's pink or red. This is pink or... This has to be pink. Because otherwise it can't access pink. This can't be yellow because that would be too many cells. So this is 2, which eliminates 2 in the rest of the rows. Row 2. So it goes medium to pink, pink to red. And pink cannot have... You can't have too many. So this can't be pink there. So this must be medium. So therefore we have a medium there. So that's 1, 2, 3. We have 6 pinks here, and we have to have 3 here. So it's either 1, 2, 3, 1, 2, 3, and this can't be pink. So this is medium. Therefore, this must be pink. This must be pink. It could go around here. So that could go that way. So one of the... Okay, so then this is boundary. Here. Here. This is 1, 6, 7, 8, 9. Cannot be 9. Because of 9 in the column. What remaining digits in column 4 are 1, 5, 6, 7, 8. Okay, so this is 3. We have 2 here. Again, it goes medium to pink to red. So therefore this has to be pink also. Guaranteed. It could do like that. It could do like that. It could do like that. You could have orange, orange, red, and then medium. That is possible. We have 4, 5, 6, 7, 8, 9. So this cannot be medium. Therefore, it's red? Could it be yellow? Could this be yellow? It can't be dark. The dark has two. It can't get there. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it cannot be yellow. This is red, which means this can't be red here. This can't be red here. That's orange, orange, so this can't be orange. That's dark, dark. So this is pink. That's 3 pinks, which means this can't be pink. That's medium. This can't be light, so therefore this is pink. This is light there. So that's done. We have pink done. So these can't be pink here. Red is done. Orange is done. Okay. So this sees 1, 2, and then 3. Because there's one change here. And it's between yellow and dark, but we don't know which one. So that's 3. 1, 2, 3 guaranteed, because that's the 4th. This sees 1, 2, 1, 2, 3, 4, 5. So this is 5, which eliminates 5 in the rest of the region. This sees 1, 2, 3, 4, 5. It needs at least one more and maybe 2. This can't be 5 because of the 5 in the medium region. Therefore, we have a guaranteed 5 here in the pink region. And this can't be 5 because of 5 in the row here. That means this can't be 3 or 5. We can't have 5 here because of 5 in the pink region already. This can't be 5, so we have a 5 guaranteed one of these 3. That's not helpful. 3 eliminates 3 here. This does see 2. It sees orange, then to red. If this is dark, the problem is dark has to go here. Because that would only be 8 if it doesn't. So this cannot be dark. Because it already has a change to here to dark. So this can't change to dark. This must be yellow. So we have that. So we have 1, 2, we have to change here. And it has to be 2. This can't be yellow because if it's... Well... No, it can't be yellow. If this is yellow, the problem is it has to go... That would force dark to be both of these, and yellow would have to go around here, and then the medium wouldn't have all the regions. So this can't be yellow. It's dark. So that's dark, which means this has to be dark here, which means these can't be dark. It's yellow. So then we have all 9 darks. 1, 2, 3, 4, 5, 6, 7, 8, 9. These can't be dark. They're yellow or medium. So this sees 1, 2, 3. There's 2 changes in column 6. This is 6 changes in column 1. 7 changes in column 3, or row 3. Sorry, row 1, row 3, and row 4, and row 5 has 7. This has to be 1. Where, remaining digits in row, okay, this one eliminates 1 here. Remaining digits in row 8 have to be 4, 6, 7, 8, and 9. And this can't be 4 because of 4 in the column. So we have 6, 7, 8, 9, which is the same digit as that, because these are all shared here. We have 6 mediums. One, no, that's not true. This sees 2. So this must be 2. This sees... We have 1, 2, 3 guaranteed. We have a 4th, 5th guaranteed. So there has to be at least one more. I think that's the last arrow, too. Yeah. Well, because we have the borders for everything but this one, right? Remaining yellow cells have to be 1, no 2, 3, 4, 5, no 6, 7, 8, or no 8 or 9. Okay. Remaining cells in column. Well, where's 1 in the medium region? Can't be any of these, so it has to be one of these two, which means this cannot have a 1 here. 9 eliminates 9 here, so therefore this can't be 9. 3 cannot be in the dark region because we have 3 here. Where is 3 in column 7 then? It has to be in there because it can't be in the dark region. Remaining cells in column 6 are 1, 4, 5, 7. And this cannot be 1 or 5, so this is 4 or 7 here. This can't be 4 because of 4 in the region. This must match this cell here because 3 is 3 here. These are the same, and therefore these are the same digits. So it cannot be 1, 5. It has to be 7. So 7 matches 7 here, which makes this 4. This can't be 4 or 7. It's 5. This can't be 4, 5, or 7. It's 1. That eliminates 7 in row 8. And this can't be 7, so it's 9, which makes this 7. No 7 or 9 here. Can't be 5 because of 5 in the row. No 5 here. No 5 here. Okay. Yellow and medium both have 2, so 2 cannot be here. Where is 2 in column 5 then? It has to be here. So this is 2. This 4 eliminates 4 here. So it's 6 or 8. This is 6, 7, or 8 here. It cannot be 7 because of 7 in the column. Where is a 7 in the red or row 9? It has to be here. So that's 7. Oh yeah, this matches that. Duh. So that means this can't be 7 here. 2 eliminates 2 here. 7 eliminates 7 here, so this is 6. So we have, oh, this was the other cell. 6 and 4, which means this can't be 4 and 6 here. No 4 here, because of 4 in the row. This is 6. This can't be 6 or 7. That sees 1, 2, 3, 4, 5, 6. Okay, well, this was going to be 6 either way. This cannot be 6 here. So where is 6 in the light region? It must be one of these. So this can't be 6 here. This is 8. This is 6. 8 eliminates 8 from the rest of the light of column 2. So this is 4, 5, 6, which forces this to be 8, which makes that 5. No 5 here. 8 eliminates 8 in here. This can't be 7 or 8. There cannot be a 7 in the rest of the pink region. So this is a 6, 8 pair, which eliminates 6 and 8 in the rest of the column. So this is 1, 7. 7 eliminates 7 here, so it's 1. That's 7, which eliminates 7 here. So this is 6 or 8. 6 and 8 cannot be in the remaining digits in pink. Okay. Okay. Remaining digits in row... Let's do columns. Column 3, 1, 2, 3, 4, 9. No 1, 2, or 9 here because of 1, 2, 9 in the row. No 9 here, no 1 here. How about column 8? Well, 8's kind of broad. Column 7. We have 1, 5, 6, 8. This can't be 1. This can't be 1. Where's 1 in column 7? It has to be here. This is 5 and 8. Eliminate 5 and 8 in the rest of the row. So remaining digits in row 7 are 2, 4, and 9. And this can't be 2 because of 2 in the column. Row 4 are 3, 4, 5, 6, and 8. This can't be 3 or 5 because of 3 or 5 in the column. 3, 4, 5, 6, 8. No 5 here because of 5 in the column. This is 4, 6, 7, 8, and 9 left. Hmm. Okay, we have 3 darks here and 2 yellows. 7 eliminates 7 here, so that's 3, which makes this 7. This can't be 2 or 3. 5 is one of these two. 7 eliminates 7 here. We have a 4, 6, 8, 9 quadruplet in column 5, which eliminates 4, 6, 8, 9 in the rest of the column. This can't be 7, no 7, no 7, no 7. So this has to be 7 here, which cannot be medium. So it has to be yellow here. So then this is boundary there. One of these has to be yellow, so this cannot be yellow here. Which means that's medium, which means this has to be medium, which means this has to be medium. So then this has to be yellow as the remaining digit. Cannot be 6 or 8. This is 4. So these are the boundaries. How many boundaries does this see? We see 1, 2, 3, 4, 5, 6, 7, and 8. So this is an 8 here. So that's 8. This can't be 3 or 8. This can't be 4 here, so this is 9. No 4, 8, or 9, so that's 6, which makes this 8, which makes that 6. So this can't be 6 here. No 6 or 8 here, so it's 5, which eliminates 5 in the rest of the column. This 4 eliminates 4 here, so it's 3. This can't be 3 or 4. This can't be 3, 4, or 8 because of the 6, 8 pair in the row. So this is 5, which makes this 4, which makes this 1, which makes that 2. No 2 or 3, no 3 here. 4 eliminates 4 here, so it's 5 or 6. 4 eliminates 4 in the rest of column 9. And this can't be 5 because of 5 in the column. This can't be 8 because of 8 in the row. 5 eliminates 5 here. We have a 4, 6 pair in column 2, so this can't be 6. This is 5. That leaves this as a 6 here, which makes this 8, which makes that 6, which makes that 8. So this can't be 8 here, no 6 here, no 8 here. We have a 3, 4, 9 triplet, which eliminates 3 in row 2, which eliminates 3, 4, 9 in the rest of the row. So this can't be 4. This is 6, which makes this 4, which makes this 9, which makes that 4. 9 eliminates 9 here, so that's 2 and 3 left. 2 eliminates 2 here, so that's 1. This can't be 9, so this is 2, which makes this 3, which makes that 2. 3 eliminates 3 here, so it's 9, which makes this 8, which makes that 9. This can't be 2 or 9, it's 4. This can't be 4 or 9, it's 3. Wow. That's a lot. Yeah, that was pretty tough. Interesting logic, though. There was some fascinating logic about, like, what the geometry of things, right? So, figuring out what region borders you could have that was really difficult. Very unintuitive, but very satisfying, too. So that was really cool. Anyways, that is the solve for chaotic choice region borders. I'll do essentially the other puzzle in a different video. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.